Hello everyone. So in this video, we tried to capture all the basics aspect of Docker, which it's a very essential skill to know or skill to have in today's software engineering world. So we tried to cover starting from the Docker, and also we tried to analyze the problem statement, and also we tried to build the image from for some project, and we also upload the image in the Docker Hub or the Docker repository. So it can definitely bring some benefit and add some additional value to your portfolio. So if you also finding it useful, then please hit the like button and subscribe the channel called Code with Krishnendu. Thank you. So Docker is an open source platform which helps to develop, ship, and run the application using the containers. So it may sounds like a little bit confusing, especially for those who are like for whom it is very new to start. So we will first target to identify the what exactly the problem statement that Docker solves, and gradually it can help or it can give us some more idea that how Docker can be helpful, right? So let's see that. So let's try to target one very common problem statement that each and every day we can face in the software development or software engineering. So let's try to address one of the examples. So we can do is, let's say I'm considering that currently one project is going on. Okay, one project is going on, and it's a typical development project maybe. And as we know that while a project basically developing, right, so we are basically using certain libraries and tools, correct? So let's say for example that we can say this project may be developed on Java, and it is on Java maybe 17 version. And also I would also we can also specify maybe the respective operating system. So maybe currently this specific application which currently or a specific service which is being developed, that is maybe happening on Windows system, right? So we can say that Windows system. All right, no problem. And also we can list down a couple of more things, maybe as part of the backend database. It is using MySQL, some random version I'm saying, let's say 5. And also we can say that it is also using maybe Kafka as a streaming platform and all those things. Okay, so for the time being, we can just list down these are the few tools and libraries maybe, so that it would be easier for understand that what exactly we're trying to do. Sorry. So let's just okay like this. And this is the guy who is maybe developing the application. So we can say that okay, kind of a person, right? And we can say that this is the dev team. So this is my dev team is currently working on that. Okay, let me just make it small, and we can say that this is the dev team. Okay, dev team who is currently working on that. Let me just complete the drawings. All right. So currently this is the person who is basically working on that, and whatever the service that being developed, right, under development, these are the things that has been used, right? No problem with that. It is completely working fine on his local machine. Now let's say there is another team. Maybe I can consider maybe it's a team of sdet, and maybe I can just draw a little bit for our understanding like this, and I can say that is the sdet team, right? Or maybe the dev team, another dev team, because we know that uh, when a software development is basically happening, so there are multiple teams are basically collaborating together. It's not like only one people who are working on the same project, right? So there should be a team, right? There should be a team where multiple people are focusing on the multiple feature development, especially if we are contributing towards the microservice world, correct? So let's say here, what we can do is right now this guy, he's maybe using a system obviously, and that system operating system that currently he is using like Mac OS, right? It's a very popular, so it can be the case he is using Mac OS. I'm just quickly copying and pasting. He is using Java. He is also using MySQL. He's also using Kafka. But here, one thing what we can do is probably there is some communication gap happen, maybe because each and everybody they're busy with their deliverables, right? So in such case, it may possible, and it actually happened, right? It actually happened in the previous stage. That's why this technology comes to the picture, where probably for so and so reason, this guy who is currently working on the same project or supposed to planning to start working on the same project, and whatever the code this dev team already built, he or she wants to contribute towards the same, but somehow he is using maybe very old version of Java, maybe Java 7, correct? Right? This can be happen. Now what's the problem? Let's try to identify. So here if we see, right, here if we see there is a clear-cut discrimination between this version. So here this has been used, or this has been used Java 17, whereas this guy is currently using as Java 7, right? And if I tell you, probably you know that after Java 8 or from the Java 8, there is a significant changes that Java or JDK library is like being integrated, correct? Like Lambda functions, arrows, and all those things. So now tell me, if this guy who developed so and so service using Java 17 as a version, if the same, and probably Java 17 obviously having their own specific features which probably integrated into this version only, right? But that specific feature or enhanced code may not be available with the Java 7. That's a very common problem. That means one, this guy going to execute the same project, right? Then and there, it will throw some error. It will throw some error, right? It will throw some error. And now this team will complain that, hey, whatever the source code that you shared with us, that is actually not working, right? Then how I can proceed further? Then again he will try to catch up with him, this team, right? He will catch up with this team, and they will try to get the details, like, okay, then probably he will say that, okay, maybe there is a miscommunication gap happened. What you can do is you simply update this Java version to 17, and then you try, right? So probably it's a only small change, maybe this team already updated that version, but still now there can be a challenge that this team or this guy can face. What's the problem, right? The problem, if you see, that's with the operating system. So this specific code or the service has been developed on Windows system. Maybe there are certain dependent tool or library has been used that is typically working on Windows, but for the same library or tool, the dependency is not available for Mac OS. That can happen, right? So for that case also, it can be a problem. So this is a very common problem statement, even though very crucial if you see. How it is crucial? Because just because of this communication of the dependencies and the configuration, the correct set of configuration, the entire deliverables has been blocked, right? They are keep on chasing to each one of them just to identify that what set of configuration that should have within their system, so that their source code can be executed very easily without having any error. And that's where this guy comes to the picture, whose name as Docker, right? Which name as Docker. So probably from this very simple example, so far till now, we probably got a very basic idea like what kind of problem statement that Docker is actually targeting to complete, targeting to solve, right? So Docker is basically targeting to solve one kind of a problem which associated with the configuration and the setup environment setupment of the code, right? So this is the very beginning. So first problem statement that we identified, that is the setup right? Setup slash, we can say that configuration, which basically indicates that dependencies, or we can say that write dependencies. Okay, so these are the things, first things that Docker is basically targeting to solve. All right, now second point that we can also understood is sometimes we have seen that to run or to deploy or to execute a big project, a big service, uh, we need a specific machine or a specific system, right, where that specific code can be executed or can be deployed, right? So probably, so what does mean it? Let's say a service is being developed in so and so localhost. Maybe in your specific computer, you are developing something, right? Now you wanted to test it, you want to deploy it, right? And that has to be like each and every time that has to be up and running. So obviously, gradually what happens is each and every service, like whenever you run a program, your system has to provide a efficient amount of memory and the execution power to it, right? Otherwise, your system can be like goes down and performance can be impacted, and gradually your productivity can be impacted. So Docker solves that problem also. Gradually, when we learn or when we talk about the Docker containerization, that time we will learn that Docker also help you to provide some lightweight containers, okay, which kind of working like a system within the Docker, which is running within the Docker. So it's very lightweight, right? And that's how the application deployment or application running going to be very easier. Even it's much easier rather than your virtual machines or VMs, right? So we can say that Docker also provide lightweight containers, okay? And gradually it helps quick and efficient deployments, which is very important for us, right? Because ultimately our major goal has to be like how quickly we are resolving on this kind of configuration related issue, and how fast we are moving towards our deployment and providing the features to our your end users, right? So that's the problem statement Docker is addressing. Now let's see that how we can actually download and install Docker in our system. So for that, it's very easy steps. So first, what we can do is we can go to the respective search engine and we can search with like Docker download. Once you search with that, you will find this specific page. So let's get into it. So once this page is open, right, you will see that there is couple of options are present, but from here we can go ahead and try to see, yes, that is called Docker, download Docker desktop. Okay, so let me tell you, Docker desktop is typically is kind of a Docker UI that is being provided to you, from where we can actually see that how whether the Docker is being started or not, and then what are the like images and the containers that Docker is currently running on. It's a very interactive, and it is recommended that you can just go ahead and download that because it will easy our job. So here, if you see that for which specific operating system that currently you are working on, that specific installer you can install, and gradually you can download and then install it. So for me, I'm running on the Windows currently, so I already have downloaded and installed this specific Docker desktop application in my system, and this is how it looks. Correct. So if I just maximize it, so here if you see that currently we have certain options at the left hand side where like Docker containers, images, volumes, builds, extensions, and so far so on. Right now we don't have any images running on here, so that's the reason it's a blank. We don't have anything into the container, so it is also blank. So once we get started with Docker image, and then gradually we will build container and run the specific image on the container, then we'll be able to see the details within the specific tabs. Now, let's talk about a very important topic, and it's kind of a backbone of Docker concept, which is called Docker image and Docker container, right? So let's take a very simple example, and we will then gradually try to like develop the points, and we'll try to understand that what does it mean actually. So let's see. Let's take a project example. So again, I'm taking a simple project example, and project example just in the like before discussion of the problem statement, we said like, let's say I have a project currently. That project probably built on the Ubuntu system, Ubuntu operating system, and as we plan to use maybe Java based technology, right? So probably for that we have used Java 8. Okay, we also have used MySQL version 8, and we also have used one mail service called Mailhog. Probably that's all. Okay, so these are the dependent library or tools, we can say, which we have used for our service development, right? So maybe I can say my services looks like, okay, API slash version 1, and I can say that it can be like get items, something like this. I'm just giving a very random example just to access that this is a service. Okay, right now if you see, these are the set of tools and the dependencies that we have. If we specifically saying, so these are the dependencies that we have, which we need to have in our system if we wanted to execute and we wanted to run the specific service on our system, right? So now what image says, because in our problem statement we already have understood that what could be the problem statement, right? That if there is a very simple way we follow the standard process without having the Docker, we can communicate and people can try to set up the things. But now as we are trying to introduce Docker here, right? So with the help of Docker, how we can come up with a solution so that it can be taken care by the Docker itself, right? And here Docker is having one feature called image, right? So if I say here, if I take a box here, and this is say for example Docker image. Okay, it's an image. Now what image does, so image is nothing but the steps we need to mention over here, that which tells Docker that what are the required configuration needs to be downloaded, and what are the steps that one should perform to make the application up and running. Correct. So if I take an example that probably as part of this application, right? As part of this application, we have Maven, right? And Maven is having all the dependencies. Now, if we run the Maven, then gradually Maven will going to be provide us the specific build for deployments. Correct. So now image, correct, but here if even though we have the Maven, then still we probably need to say that okay, even though you have Maven, then you need to first do the Maven goal execution, right? You need to do the Maven clean, you need to do the Maven in compile, correct, Maven compile, and also you need to do the Maven install, and then probably finally you are being able to generate the specific builds. You are being able to generate the specific builds, correct? So here if you look at these things, right, to execute and being installed or configure our system with the required dependency, we are running so and so steps, right? So image, what image does is, image is saying that okay, you tell me what needs to be done, you tell me what needs to be done in terms of setting up the environment or the system to make it capable or to make it enabled one so that this application can be up and running, and what are the steps that one user should perform so that the application finally going to be in a state where people can directly use it, right? So image is saying, you just tell me what needs to be done. I will do all the setup, all the pre-configurations, and I will run all the steps, and I will make sure that all type of dependencies are already there. Now people just come, like user just come and start using it. As simple as that. So image is basically contains the steps. So if I just write very easily, so probably I can say that first you need to install Ubuntu, okay, because we wanted to make it in a common position in a common operating system. Then I will say that you download, or probably I can say that yes, you download Java 8, correct? Then I will say that you also download Maven, because it's a Java project. Maven we need. Then you run mvn clean and install command, right? So these are the steps that we are telling to the image. Okay. So what image will do is, finally, once these commands are done, once run maven mvn clean install command is run, that means what? Like, we can expect that the respective file, whatever is there, now it is in a position to up and running. So finally, once this specific mvn clean install step is completed, then we are also saying that okay, what it's gonna like generate a jar. Then you probably initiate a cmd, and you specifically run java hyphen jar and your service.jar file. That means what? Like, you are actually telling to the image, right? Docker image, that in terms of make this service up and running, these are the dependencies that we want. Okay, we wanted to make a common operating system which is called ubuntu. So we are saying that, hey image, while setting up the project, you please install ubuntu first, right? Then we need java 8. Then we are only telling to the image that you please download java 8. Then we need Maven. You please download the Maven. Probably we also need the Mailhawk. So I can just add one more line over here. So I can say that download Mailhawk, which is for our email service, right? And finally, once this is done, this configurations and this download part is done, you simply do one thing. You please run the maven command, whatever is there, right? In terms of generating the build, that is npm clean install. And once it is completed, you simply run this java-jar service.jar file so that people can be able to use this specific service by their system. So now if you see that image, as image contains all these steps, that means this user, if I go back to the problem statement, so this user do not need to perform it manually, correct? Now it is completely automated. If you see, that means this entire conversation where we had so much of confusions, now it is finally resolved. Now the second question is, who going to write or who going to create this image? So it's ideally the respective dev team's responsibility to create this image. So if I say, so here I can mention that dev team, or the team who is actually building this service from the scratch, they have to write this, or they have to create this image. Okay, there is a concept called Dockerfile where we will come in some time, right? So under they have to create a Docker file in their specific project, and Dockerfile is actually contains all these steps, okay, that what you supposed to do. So if I wanted to make my application kind of an like ready-made, right? Like plug and play. So what are the things that you're supposed to do? So these are the things that you need to do, and those pre-configuration things are already been written in a such a way so that people or the user do not worry about like what they're supposed to do. They do not need to worry about the versioning. They do not need to worry about the downloading. Okay, even environment management, all they need to do is um, they can simply get the image, and then with the help of Docker they can simply download the image, and finally they can run the image, and that's all. The job is done. The entire setup of to run this application is completed. Okay, so this is image basically does. So image is nothing but a configuration, steps of configuration and step which one should run to make the application up and running. Make sense? Now let's say we have one more component which is called container, right? Which is called container. So I'm just trying to come here. So now if I tell you from this specific example that we all are using computers, right? We all are using computers, and we know that to run so and so application, correct? Probably you wanted to run maybe this Chrome browser, right? You wanted to run the Chrome browser, so you need what you need. You need the Chrome installer, right? If I say that you need a Chrome installer file, right? And also you need, what do you need? You right, you need a Chrome installer, and this installer, what it will do is, if we follow the steps, then gradually it will start running all the steps, and gradually you will be able to see the Chrome, correct? So so where we have ran this installer, to run this installer we need a computer. To run this installer file we need a computer, right? Correct, because without having the computer we cannot run any application, correct? It cannot be installed, or we cannot make use of it. Now if I assume, okay, image also behaving like same, correct? So image also giving me all the steps which needs to be executed in terms of making so and so service up and running. That means it's behaving like an application, right? Because we do not need to do it manually. But the question is where this application should run. We need a computer then for that, right? So to run the image, we need a computer. And in Docker world, that specific computer known as container. In Docker world, that specific computer known as container. So it sounds very easy now. So containers are nothing but a Docker managed and Docker created system where your images are being installed and running, right? So in a very layman language, if I say containers are nothing but Docker created and managed container where images can run, and this is actually happening within the Docker. Okay, so that's how it is. Very simple. So that's the reason that Dockers, these two are Docker's fundamental. And if you see one thing, like now Docker is completely taking care of this entire thing, right? So not only your pre-configuration step where your all the details has been mentioned, that what you need to make your system capable enough to run so and so service, Not only that, but also where and how you should execute your program or the specific service, that is also being taken care by the Docker. That means now we are getting an independent environment to run our services, correct? And the very powerful thing is, so container and image are very powerful feature of Docker, and this that's the reason these are the backbone of Docker. And not only that, now probably you can have one question in your mind that okay, we are creating an image which nothing but kind of a configuration file which contain these many details, that and out of this image we are creating a container and then we are running the image on the container. So that means like container then also going to take much and much spaces, because Ubuntu is an operating system, Java is there, there can be other databases there. But the actual interesting fact is images are very lightweight. Okay, it's a very lightweight, and probably in other time if we see so and so operating system comes in a GB memory size it's consuming, whereas image, where it comes to the Ubuntu image or maybe the Windows image, it comes to a very small file, maybe it comes to only some MBs. Okay, so that's the power of having the image and the container of Docker, right? Now let's see that how we can install an image, right, on top of the Docker, and how Docker can install the specific image on its managed computers, which known as the containers, right? So let's say this is our local host right now on which system that I am on. Maybe currently I am on the Windows system. So on Windows system, I already have downloaded this Docker desktop with me, and which essentially help me to initialize the Docker. And now we are planning to install a very famous CI/CD pipeline tool, which is called Jenkins, on top of this, right? And then what would be our expectation is Jenkins going to be downloaded and gradually it is going to be installed in some system, right? And that system going to be managed by and created by the Docker, right? And from our like last discussion we know that system is known as the container, right? So let's try to achieve this, like how we can do that. So before getting into that, we need to learn or we need to know about few of the commonly used Docker commands, which are actually essentially can help us to cope up with or to communicate with the Docker, right? So what are the commands that we need to know? The first command that we will use, which is called docker pull, and the image, that which image that we are trying to pull, the that is something we need to run. Okay, so here the pull, right, here the pull we can correlate with the terminology called download. So when we say that, hey Docker, you pull some image, that means we are saying that you download the specific setup file into the system, correct? Now we have the image or the setup file with us. Now we need to create a container where this image can be installed and run, right? So for that we need to write one more command going forward, which is called docker run -d, and then the specific image that we have just now we have downloaded, that image reference we need to supply, right? So when I say image reference, so image reference can be the name or the ID of the image, correct? So going forward we will also see that few of the flags that we need to introduce in terms of running a specific image on certain container. Okay, so right now if you see that here we have introduced one additional flag which is called -d, right? Now what does it means? So -d stands for detached mode. Okay, detached mode means what? Like when we start a container along with some image. So we know that image is nothing but a configuration file which is supposed to be installed to the container. Now, if we do not supply this additional flag along with our command that we are writing to initiate or create a container, then what will happen is our command will directly get into the container and start the execution. And we were unable to use the specific terminal window for anything else. Okay, we will directly get into the specific container, and that's the reason it is required that if we supply this flag which is -d, that means we are saying that okay, you have started the container is now up and running. Now you just free the terminal so that the same terminal window we can use for the other purposes, right? All right. So let's try to see that. Now the question is, we said that okay, Docker pull image. That means we have to know about the image reference, correct? Because it is not like I just get into the Docker or get into the command prompt or terminal. Directly I will write the command and Docker will start working on that. So I need to supply the valid image reference as well. Now the question is from where I can get the valid image reference. Okay, so for that we have something called Docker Hub, right? So what's the Docker Hub does? Docker Hub is kind of the repository. Okay, it's an image repository that managed by the Docker. Okay, so now if I give you an relatable example, so we all used Maven repository, right? From where we can get the Maven dependency or Gradle dependency for so and so libraries, especially used in the Java. Similarly for the npm for Node.js, right? So similarly, Docker also managing one repository which is called Docker Hub, and this Docker Hub contains all the required libraries, which whatever is there or whatever is being hosted. If it is made at public, then we are being able to use the same. Okay, one additional info is Docker Hub. Right now, if say for example I have written a program, I developed a service, now I also wanted to host my service to the Docker Hub repository. Question is it possible? The answer is yes. So Docker Hub also giving us the feature, like giving us the flexibility where we can actually host our own developed service there. Okay, so we already have that topic listed. We will go through and we will try to learn about this. Just stay tuned. Now, once we are here, that is Docker Hub, right? Here, what we can do is, so as per our diagram, we are targeting to download Jenkins. So let's try to search with the keyword called Jenkins, right? So once I search with this keyword, I can see here a couple of things. A couple of Jenkins images are present, right? Now from here, how shall we know that which image I should go for? Because it's an open source, right? So there can be like multiple publisher who are actually uploading the image. Few are like official image, few are verified image, few are sponsored image. So what we can do is we can check this box which is called Docker official image and verified publisher. Sorry. So here, if we try to see that, we have something called Jenkins, right? We have something called Jenkins over here, and here if you see that it is giving us few of the information that it is being deprecated. Okay, now it is being deprecated because it is saying that okay, let me check anyone else because it is looks like a deprecated image, so the support may not be available. So let me do one thing. Let me go ahead with this sponsored I need to see. Yeah, it is by Jenkins. That means Jenkins community only upload this. So let's go ahead with this, and latest thing happened on the Jan 6. So what we can do is we can see that yes. So this is a Jenkins official, and Jenkins team is actually updated this one or uploaded this one, right? So far 1 billion plus download happened, and this is the command that we can get. So is it relatable, right? If we see in the command segment, we mentioned that we need to specify like Docker pull and the image name. So similarly, if you see the same command is mentioned here as well. correct? Now how we can do that? So for that we need to have our Windows. If you are on Windows, then you can open the command prompt or Windows PowerShell. If you are on Mac, then you can open the terminal, right? And you just need to make sure that you already started your Docker desktop instance, because internally Docker is having a Docker manager which is called daemon, Docker daemon. Okay, so that is actually managing entire Docker system behavior. So if you have the Docker desktop installed, then automatically it will be invoked. So you do not need to do anything else. Okay. So if it is started, we can visualize like whether we have any image installed or not. So far, currently you can see the window is empty. Similarly, there is no container is there, right? So our expectation is, if after running the Docker pull command, if it is succeeded, we should be able to see and Jenkins image listed over here, correct? So let's give a try. So what we can do is we will say docker pull, and what's the image name that we have seen? Let's go back to the browser. So Jenkins slash Jenkins, this is the name of the image that we need to just copy. And if I go back to the window and we can hit enter. Once you hit enter, it will start downloading the latest version, right? If you see one thing here, that using default tag is latest, that means what? Let's say if I take a very random example while it is downloading, let's say I wanted to download a Jenkins version. I wanted to download a Jenkins version, the version probably randomly I'm taking, that is 5.6.2. right? Now, if I wanted to do that, then how I can specify the version? So I can write docker pull Jenkins, the similar thing we can say Jenkins slash Jenkins colon 5.6.2, right? So like that, what we are trying to achieve here is, we are basically saying that we are specifying the version of the Jenkins, that hey Docker, while you are downloading this image, please consider this version. Okay, and this is also known as tag. This is also known as the tag. So with the help of the tag, we can actually specify the version of the image that we wanted to download in our system. Make sense? Now if I go back to the window, currently we haven't specified any version, right? So that's the reason what Docker will do. Docker will understand that okay, user haven't specified any version, that means user probably looking for the latest version of it. That's the reason if you see default tag is latest. Makes sense? Now if I go back to the Docker desktop, you can see there is an image which is already been listed here, which is called Jenkins, correct? And similarly, if we wanted to see within the container, there is no container started, because we know container is nothing but the like machine that has to be created by the Docker, which contains this image, right? Now, say for example, apart from the Docker desktop, is there any other way that we can get what are the images already present in our system? The answer is yes. So for that, the specific command that we can use is called Docker images. If we write this command and hit the enter, right now if you see the same name of the image we are getting, where repository is this, tag is latest, image id is this one, and created is 6 days ago. So here please don't confused with this number, because you may have question in your mind that okay, I just created or installed this image right now in my machine, but still it is showing the 6 days ago. Why? Because the specific version, the latest update from the Jenkins community that they pushed to the Docker hub, that happened 6 days ago. So this is means the latest update that is being available into the Docker Hub for Jenkins, that happened 6 days ago. So that is what it is created, and total size is 467 MB. If I, as I mentioned, like images are very lightweight, right? So we already have the image. So similarly, as we ran the command called docker images, is there any other command also available to know whether some container already initiated or not? Yes. For that we can write docker ps hyphen a. If we run this command, if you see, currently the container, so it's kind of a tabular format, right? Where container is empty, image is empty, command created all entire columns is actually empty. That means none of the containers are running which contains this image or any other images, right? Now there is one more command we can actually use. It's just a modified command of the previous command, which is called dockerps, right? Dockerps, and it is also giving us the same type of output. Now the question is, then what is the difference between two? Right, we have executed two commands. One is docker ps -a, another one is docker ps. So here the concept basically lies that or depends on that key which container is currently active. Docker PS only giving you those container details which are currently running and in active state, whereas Docker PS -a is a flag that means all. So basically that specific command returns you that doesn't matter whether any containers are running or not. Okay, it will give you the entire list. Okay, so docker ps-a going to provide you all the list of the container, doesn't matter whether it is active or not. Docker ps without having -a, it's only providing us the active or running containers only. Make sense? Now let's try to run this specific, or let's try to create a container which can contain this image. Okay, so everything we will manage via command only. So for that we will clear the window and we will run the command that we have documented, which is called docker run -d, right, -d, and we can also specify the specific name. Okay, let me come to this example after this. So let's say I am specifying this is the image. This is the image ID. As I mentioned, here I can supply the image ID as well as or the image name. Anything works. Okay. Now if I hit the enter button, you can see I have got a big number, right? A big number I have got. So what is this? This is nothing but your container ID. That means we are successfully initiated or created a container within the Docker. How we can verify? So we can say docker ps-a. See, previously it was giving us the empty table. Now it is having some details, correct? And similarly, if we wanted to re-verify, so we can go ahead to the Docker desktop, go to the container, and we are being able to see that. Here, one thing, if you see that currently this is the specific container that we have created, or we have or Docker have basically initiated using that image that we are having, right? So we can verify via this image ID here. And also if you see there is a small image ID is also specified. So if we just try to verify, like it is starting with B917D. So here also it is like B917D. So that means whatever command is returning to us and whatever we are being able to see visually on the Docker desktop, both are same, correct? Now one question over here, one thing over here is, right now if you see that okay, so right now if you see that we have a name, right? So this is something called container name. Okay, even though if you come here, so you'll be able to see this is the name, right? And now one question can be in our mind, that how this name came, because we haven't specified any name of our container, right? So basically, so this name is actually supplied by the Docker. So whenever creating any new container, Docker specified a logical name there just to identify it, so that we can differentiate. Now the question is, can we update this name? Say for example, I wanted to I wanted to create a container which running Jenkins on top of it. I would like to say that the container name can be Jenkins-container. Is that possible? The answer is yes. How? So for that we can create another container. So for that the same command we will run, docker run -d. Then the another flag we need to introduce, which is called --name. This time we will say that Jenkins container should be my container name, and you run this image on top of this. Hit enter. So I can see that another container is also created. Let's try to run docker ps. This time if you see, I have two containers created. One was my previous one where name has been provided by the Docker itself. Second one is the customized name, customized container name that we have supplied. Similarly, if I go back to the Docker desktop, see, this is the Jenkins container, the container we have created. Make sense? Now, probably now, furthermore, that what we can try to do is that, okay, we have initialized the Docker. We have downloaded the image. We have created the container on out of the like which is actually running the image on top of it. We rename the container name, correct? Now the question is like, okay, say for example, now I wanted to stop the container. I wanted to stop the container. Maybe whatever the things I wanted to do in the container, the execution is done. Now I wanted to stop it. Is it possible? Yes. So for that, we have two different things. Like one is you can stop the container and then you can remove the container. Because if you are stopping the container, that is not meaning that you have deleted the container as well. Because as Docker says that it helping us to memory management as well, right? So if something is not needed, then we do not need to keep it, right? So first there is a sequence that we need to follow, that unless we stop a container, we cannot remove it. So for that, what we can do is, let's say I'm targeting to stop this suspicious underscore world's container. So let me copy the container ID from here, and we can say that docker stop and the container ID. Now if I press the enter, if you see, it is returning me the same container ID. Now if I wanted to verify that whether my container is actually stopped or not, so we can simply run docker ps. Okay. Now if we see, as I mentioned previously, that docker ps only gonna return those container which is currently on running state. So as the second container is already stopped via this command, after running this line, it is not included, right? So if we wanted to cross verify this, we can go to the Docker desktop and see right now this container status is exited, correct? That means it has been stopped. All right. Now let's say I wanted to delete this container as well. So for that, the command is docker rm. Rm stands for remove. Okay, and the container ID. Hit enter. Um, okay, so it is saying that okay, my bad. So I supplied some wrong container ID which is already running. So as I said that if some container we wanted to remove, first we need to stop it, but I supplied the running container ID, so that's the wrong. So I need to take the previous one, right? So this is the container I need to see. So I need to say docker rm remove this container, and see that is there. If I go back, see, the container has been removed, right? Similarly, if I wanted to remove or wanted to stop and remove my running container as well, so for that I can specifically copy the container ID, or just for your information, you can also specify with the container name. So let's try with container name. So you can say that docker stop container name and container is stopped. Let's try to verify whether it is stopped or not. Yes, it is removed. It is not present under the docker ps command. That means it is stopped. Even here also it is stopped. Now we can simply say docker rm, the container name or id, anyone you can specify. So right now it is giving me like this. So container is empty, right? If I go to the images now, you can see that still image is there, because as I mentioned previously, that image is nothing but a setup file kind of. It's a configuration file, right? So image is already present. So whenever we need, we can just create a new container which gonna contain this image, and it will up and running there. So let's say for example, I also wanted to remove this. I also wanted to delete this or remove this image from my Docker as well? Is it possible? So for that, the another command that you need to run is docker rmi. So for images, we do not need to stop or start something like that. Okay, because it's an configuration file itself. It's just there. Okay. So rmi, if you observe the command very specifically, so we just introduced one more word which is called I. So RM stands for remove and I stands for image. That means we are saying Docker, you remove the image. Which image Docker should remove? So image name we can supply, which is this. So if you see, it is saying that untagged, that means everything is deleted. Now if I run the command called docker images, it should give me an empty table, right? Similarly, if you go back to the docker desktop, your image should be empty now, right? So like that, this is the like docker image and docker container, like how we can download docker image, and then how we can create a container to run that image, how we can stop it, remove it, and run it. Correct. Similarly, for a project, we know that it is not always necessary ki we only gonna have one image or one container. No, to run or to work on some project, we can have multiple libraries or multiple dependencies or multiple images we may need, right? Just like if I say that, okay, I need Ubuntu, then I need maybe the Mailhawk. So for each and everything, if you type as a keyword and get into there, then if you see there is an Docker pull command is already available, correct? So one more thing we can see, maybe I wanted to have the OpenJDK, right? So for OpenJDK also we have couple of publishers, right? And this is the Docker official image. We will try to go ahead, and this is the respective command that is being provided, and this is how we can download whatever we want. We can just download, we can bring to our system, and gradually we can create the container. So that's all. That's about the running the Docker image and the Docker containers, right? Okay, so now let's understand the concept called port mapping. Okay, it's a very important, even though very easy concept within the Docker. So far what we have seen is that, say for example, this is our system. From this system, and we have a terminal, and from the terminal, let's say this is the command that we are supplying, that we are saying docker run -d jenkins slash jenkins slash Jenkins, right? So what this command actually doing here is, so once we run the command, uh, so this command is actually goes to the Docker, is actually going into the Docker. So let's have a Docker icon, and we can put it like this. And once Docker understood this, that means Docker will understand that user is actually asking the Docker to initiate a container. So what it will do is it will basically create a container for us, and it will install Jenkins over there, right? Like this. It will install Jenkins over there, right? So yeah, we can map, okay, this is our container. So from the from the discussion, we know that whatever the container is being created, right, that is actually happening within the Docker. Now we know that the default port for Jenkins is, the default port of Jenkins is 8080. But here the interesting thing is, this container, which is nothing but a computer which is created or instantiated within the Docker instance, it is actually there within the Docker. But what we want is, we wanted to make a connection. We wanted to make a connection from this Docker to our actual local host, correct? Then how we can do that? Because ultimately, because if we wanted to get into the Docker, then we may not be able to see the Jenkins UI, correct? You know that we have Jenkins UI.
which can help us to create any job and set any pipeline very easily. But if we wanted to get into the container, then we have to write so and so commands. That can be a little bit difficult for us. So what we want is that, okay, even though currently that Jenkins is actually running on top of the container which is created by the Docker, we wanted to have that same Docker Jenkins instance to be mapped with our machine's port. Okay, so what we can do that, we can probably say that, okay, we can probably tell to the Docker that, hey Docker, wherever you have the Jenkins, we know that it is an 8080. Okay, so we can tell to the Docker that, Docker, please map your 8080 port with my local system or my local host 80 port. That means whatever Jenkins instance is running on the Docker container port 8080, the same thing, the same Jenkins instance we can map with our systems. That means our machines port 80, so that it would be easier for us to access it and create whatever the activity that we wanted to do via the Jenkins UI. Okay, so for that, we have to introduce one flag in this existing command. So the devised command can be docker run -d, which stands for detached mode. One more new flag we need to introduce, which is called -p. P stands for port. Now we will say that containers 8080 port can be mapped with our system's 80 port and then the image ID. Correct? It can be ID or name. Okay, if we try to understand this command, so here this 8080 is the port where our Jenkins is exposed within the container. So it's a container port. And in my left hand side, this 80 is the port where we wanted to map this container port. That is our current local system port. Okay, so let's give a try and try to see that whether this thing works or not and how it is working. For that, we can go to the command prompt or terminal. Let's clear this window. So we already have a Jenkins instance running, right? So it is a docker ps. So this is the container is running. So probably we can just stop it for now because we are not gonna using it. So we can say stop, and we can also say remove this one. Now we will say that docker images, because we need the image ID. So this is the image ID. Now we will say docker run -d -p containers 8080 port can be mapped with our system 80 port, and also we wanted to install this image on top of that. Now we have got an image and container ID. Let's try to cross verify. If we go to the Docker desktop and the container tab, so this is something is already running, and if you see, the map is already happened, right? Now let's go back to the our browser, try to write localhost, and the mapping we have done on the 80 port, and here is it is, right? So currently we are saying it is giving us the Docker UI which is currently loading, right? So that means that port mapping is happened properly here, correct? So this is the port mapping. Now port mapping, the use case for the port mapping can be multiple, right? So there can be multiple images or multiple applications which are available over the internet, right? So there is an application called Mailhog, right? So it's a service, right, which can help us to test our email service. So if we go there, right, so and if we wanted to integrate this application with our own our own service, right? So there also we will be able to find that how we can do it. Okay, let me try to go to the Docker Hub. That will be more easier to see. Docker Hub, if I go and if I just try to search with mail hog, right? And maybe there, and if we see that, it is also saying that, okay, whenever we are trying to run the mail hog, we can expose the specific port to the 1025, right? So this is basically um, it's basically help us to identify or to specify that, okay, if we are running multiple applications, right? Say for example that to build a service we need couple of things, right? We maybe need MySQL service, we maybe need email hub to run some email services. So we wanted to specify certain port by default, because it may possible that wherever that application is supposed to run, right? So they may not have the port already available for that application. So we are explicitly saying that to run this application, these are the port that is required, right? So now if within the Docker container we already reserving some port maybe by default, right? So in our local host, in our local system, how we can map the port so that we can access via our local host itself. When I say local host, that means our current system or laptop, right? So that is where our port mapping can help us to do it, right? Now we will try to learn that how we can dockerize an application, right? So this is basically the hands-on. From here, we will try to utilize the Docker for our service development, right? So for that, let's try to outline that what exactly we will try to do here. So first, we will try to develop a very simple API, okay? A very simple API using very simple way we will just develop using express js. Okay, so using express js we will try to build a very simple api, and then what we will do is we will then try to create a docker file. We will try to create a docker file, okay, which this docker file going to contain all the steps that if someone wants to set or someone wants to build this API, whatever we are going to develop in their own system and wanted to execute, then what are the steps that they essentially followed. And finally, once this is done, then we will try to upload this specific service within the Docker Hub. Okay, that's the repository that we already discussed, right? So this is the outline of the activity that we are planning to do now, right? So for that, first we will open our like VS Code. This is the editor that we are going to use. Let me try to just the font. Fine, right? So as we know that first we need to have the dependency. So for that, what we can do is we can go to here. We can type express.js. This is the express.js part of node.js, and this is the dependency that we need to have. Let me copy it and going back to the VS Code. So first we will type npm init, right? Npm init, that is something we will just type to create our very basic project structure, right? So this is something it is saying. The package name, yes, we can have it. Version can be the same. Description, we can say that simple express API for Docker, right? I think we are writing Entry point can be this, test command is nothing, git remote is nothing, keyword is nothing, author we can say Krishnendu, and license nothing, and yes. Okay, so here missed it. So this is what we have created our package.json. Now once it is done, we already copied that specific line from express.js official page, right? Which can help us to save the dependency for install and save the dependency for the express.js. So let's try to download it and save it. Now the download is started. Let's wait for a few minutes. Yes. So now um, our project is ready. The basic structure of the project is ready, where I have this Express version 4.21.2 has been installed. It's the latest version, and okay. So we are good to go. Now we will simply create a .js file. So I will say that okay, index.js, and here we will say const express. First we will take the reference of express and assign to here. It should be like require, we wanted to have express here, then we wanted to have another const and that for our application, and here we will initialize our express like this. Then we gonna need the port. So port we will try to assign from the environment as an environment variable. If user wants, they can have it. Sorry, this should be the process dot env dot port, right? If user wants to execute this service from so and so port number, that is possible. Otherwise we wanted to execute the service on by default on 3000 port. Now with the help of app.get, it would be very easy to write. So we will say, maybe I'm just trying to create an API and that can simply provide me some values. I will say value and comma one callback function with request and response. And then here we will say that you return me the response. Okay, you return me the response in the format of like this. So I will say that once this endpoint got called, you supply me a message, and the message can be hello from Docker. Okay, this is the message that we can have, and once it is done, then we are also trying to print over the console that our app is basically listening on some port, and this is the message that we can say that console.log, and here we will say service is listening on port. So here we can say that this port, right? So we are passing the variable here, whatever the port number that we will get either from the user as part of environment variable or the default port that we specified, which is 3000. Now if we wanted to execute this, which is our index.js, so you can see service is listening on port number 3000. Let's try to verify this if we are getting the output or not. So we can say localhost and 3000. It is saying we cannot get. Okay, so my bad, because we specified the endpoint as value, correct? Yes, we are getting this value, right? So for our like quick reference perspective, we can also use Postman, right? Because ultimately it's an service. So we can use Postman to hit this API or hit this endpoint. So let it be loaded. Right. So in the Postman, we can see that our service is actually working here as well. Right. So if we, I just onboarded the same URL over here. and we see that the endpoint is actually returns me the hello from Docker. Correct? So right now, this is the service that we developed, and if I just off this service for the time being, right? So it is working as expected. Now, this is the first step that we have completed, right? This is the first step as per our outline. This is the first step that we have completed. Now, this is the second step that we wanted to do. Now, if you remember in our previous discussion, we said that Docker file basically represent the creation of image, right? So Docker file going to have few steps written which can tell to the system that this is how you should have to like download the dependencies, and gradually via the command that we are going to provide within this, it can also start like executing the specific image, correct, or downloading the specific image by default. So the same thing we will be doing here for our project. So for our project, we will create another file, and the name of the file we will put as Dockerfile, right? So the file format, folks, it should be like this, okay, Dockerfile. Otherwise, Docker won't be able to understand it. So now here, from here, we will start writing, correct? So there are a couple of syntax, couple of reserved keywords are available, which we need to apply here. Okay, then only our Docker will be able to know that okay, this is how the that user wants to install, or user wants to install all the pre-configurations at part of our application. Okay, so before that, let me just try to see if I and zoom in a little bit. Yes. So now at the very beginning, what we can do is we can say that to run this service, we wanted to have one common operating system, which is called Ubuntu. Okay. So for that, we will write from Ubuntu, Ubuntu, and we will also specify that which specific version that Ubuntu can have, which is I am specifying 20.0. 20.04. Okay, so this is the specific version of the Ubuntu that we can use as part of our application run. Okay, this is the operating system we want. Now, second thing is, as you know that it's an Ubuntu operating system, so we need a package manager, right? So just like our npm is being used to download or manage the package for Node.js application, right? So within the Ubuntu operating system, we need to have one package manager which can help us to download and install any tools or library within it, and that's called apt-get. So before executing it, we wanted to say that once you have the Ubuntu installed, downloaded and installed, then you run this command which is called apt-get install. Sorry, before install, we would like to update it. Okay, first you update, then you can install it, right? Now the second step we will say that run apt-get and then we can run the install command. So here if you see that in terms of running this application, right, if we go back to the whiteboard, so we have built one application on express.js. Now if I wanted to list down the dependencies, that okay, if I wanted to share this code with you, then what are the dependent things that you should have it? So you need to have the Node.js installed, correct? You need to have the Node.js installed, because without having the Node.js, express.js cannot be there, right? And our application cannot be up and running. So what we understood is Node.js is essential in terms of executing this. That means we also instruct uh, also need to provide the instruction into a Docker file that you download this Node.js, right? Now, there are multiple ways to download the Node.js within the Ubuntu. So you can see, so one of the way to download and install Node.js within the Ubuntu is curl. Okay, so we will say that curl command to download Node.js in Ubuntu. Okay, so this is the first article. Any article you can follow. If you see, so it will guide you that how you can actually do it. So there are multiple things. So this is one of the way that we can do it, which is saying that we can just get this command, which is called curl and then -sl. This is the URL which we can use in terms of downloading the specific Node.js version. And then finally we can set up this. We can run this .sh file, or we can also initiate the bash. Okay, so let's try to do that. So before run the curl command, curl is a tool, right? We also need to have the curl into the system, right? So right now the container is completely empty. We don't have anything. We don't even have the operating system. So we have installed the operating system. So we need to install the curl as well. So here I will say that run apt-get install-y and you download curl first. Now, if we say I have specified one flag called -y, what does it means? When we say -y, that means we are trying to say that while installing this application or this tool within the container, right? If any such permission is required, we are giving the full authority to our Docker, that whatever the permission you need, we are literally saying that you kind of a administrator here in the application, and you have all the rights to make the changes, right? So if you see that sometimes while installing the application, we there is a pop-up comes and it asks for the permission. We have to click on the OK or yes button, right? So something like this, you can correlate like this, right? So now once curl we have, now we wanted to run another command, and this time we would like to use curl as a tool to download the uh, node version. So let me get the node version from it. The specific node version that we wanted to have is, this is the node version we wanted to specify, right? And once it is done, we wanted to have the bash, right? All right. Now, once this is done, so we have installed the Node.js as well. After that, we have to run apt-get, because without having this, we cannot install it. So now we are telling to the apt-get manager that, hey, our curl already helped us to download the Node.js within the system. Okay, now you install the Node.js in our system. Okay, so this is the line where we downloaded that Node.js within by using the curl as a tool or curl command. Once it is downloaded, now in this line we are saying to the package manager that please install Node.js within the system, right? Once it is done, we will simply say apt-get clean, just to make sure that if there is any garbage, it can clean automatically. And also we can also print the version of the node too. So if node install properly, then this should work, right? That is node-v, and we can merge multiple commands in one line. And also we wanted to print the npm version. Npm is a package manager for node, we know that version we wanted to print, right? So this is just a verification that if node.js installed properly, then it should give us the node version as well as the npm, that is node package manager version. Now so far, if you see, these are the steps these are the steps which are basically saying that install dependencies, right? Install dependencies. So this is the whatever the dependencies we need, that is something we have done here, right? Now we need to set our project, because ultimately what we need to do is, once our these steps are done, now we wanted to run our this project folder, because without having this project folder our service cannot be executed, right? So for that we will use a command called copy. Okay, copy what we wanted to copy. So from this specific project structure, if you see in our left hand side, we have couple of things, right? So let's assume like this, that today I have this project with me. Now I wanted to share this project with you, right? Then what are the dependent things that you need to set up this project in your system? So if I go back to the whiteboard, so one is Node.js, that is something we need obviously to execute the program. Now, as part of my project, you need that package.json file, probably package-lock.json file, and you also need my index.js file. Node modules is not there, because if you have the package.json properly placed and if you execute that npm install command, then automatically the dependent services and node.js module automatically going to be created. But you need this. If you don't have it, then you won't be able to download all the required dependency like express.js and all, right, within the system. And if you don't have index.js, then you won't be able to run the code that we have written right now, right? So the same thing we are saying, because right now these things we have in our local machine, but we need to transfer this, we need to copy these things from our local to the container that is created and managed by Docker, right? So we are saying that, hey Docker, you copy package package.json file and create another package.json file within the container. So if you see, I have specified two things. One is this package.json, this package.json, and another one is this. So this is called source, this is called destination, right? So here one thing is when I say source, that means this package is from my local, and when I say destination, so this package.json which is going to be placed within the Docker container. Now the thing is like, question can be like, is it always needed that this package.json name should be common? The answer is no. Okay, it can be anything, like if you want like package hyphen service, something like that, so that new name also we can provide. Okay, so whatever the name we supply, the same file going to be paste within the container with this updated name. But as part of the good practice, it is suggested that whatever the file you are copying, just try to maintain the same name in to our destination as well. Okay, so that's the reason we are maintaining the same name. Now we also need to have package hyphen lock dot json file, and similarly we will not change the name to our destination. We also need to have index.json, and sorry, it should be a JS file, and we also need to have index.js within our Docker container, right? So here the step name we can specify is that copy the required files to destination, right? Now next part is, so now we have the dependent libraries and tools are already installed. We already copied whatever the required files we need in terms of making our project up and running. Now we need to execute it, right? So to execute it, we are going to run a command called npm install, because npm install is the command, if you know the basics of node.js, right? So npm install is basically a command which can help you to, which is basically targeting to execute the package.json, and whatever the things you have within the package.json, it will download and gradually it will set up your project. Like node modules, it will create automatically. Node modules we were not going to copy and to our destination, right? Because it's going to be heavier, and anyways package.json already having the info. Now, once npm install is completed, we need to specify an entry point. Entry point means for this project, right? For whatever the project we have created, what is the entry point of our project? For this specific service, our entry point is index.js, because that is where we have written all the code, right? Even while running also, we mention like node then index.js. So the same thing we just need to specify here, that once your setup is done, your npm install is completed, which going to be the entry point of your service, so that that can be triggered, and gradually whatever the other files, dependent files are there, that is going to be initialized as well. Okay, so for that we will say that our entry point is index.js, and that can be executed with a node command. So we can supply multiple values like this. Makes sense? So this is basically an array which contain multiple commands. So node is the command we need to specify so that we can run our index.js file, and index.js is the entry point from where our service is actually there. So this is our typical Docker file that we have created, and that's all. That's what the steps that we need to define. Here one thing probably it can come to our mind, that we are writing from ubuntu and some version we are specifying, then from where this ubuntu going to be downloaded, right? So if you remember, we have gone through this docker hub, correct? Where it is, yeah, docker hub, right? And we already have seen that if we search here like ubuntu, so you will see Ubuntu is already present, correct? So what Docker will do, when Docker will identify these steps that user is saying that you have to start with Ubuntu, Docker will go to the Docker hub internally, and it will take the pull from there and then gradually run all the steps whatever we have documented, right? Now once we build this Docker file, right? Now we need to build, well, once we have completed writing this docker file, now we need to build the docker file. Means ultimately you need to create an image out of this docker file, correct? Right? And for that we have a command. So what the command that we can execute? So before that we wanted to see the docker desktop, how it is looking. So right now in the image segment we have only one, which is Jenkins is currently up and running. So expectation is, if going forward whatever the build command we are going to use to build our image, if that got succeeded, then we will be able to see another application which is going to represent our own service. Okay, so what would be the command that we need to use? So to do that, the command we need to use it, docker build hyphen t, right? Hyphen t, which is a flag which is basically used to specify your specific image name and the image name that you wanted to specify. So we can say that docker service and dot. Okay, now you hit enter. So once you hit the enter, if you see, it starts executing each line one by one. So first it is pulling that ubuntu, then it is copying the package.json, running the npm install, and once it is completed, finally it will start this index.js, right? If you see, now our installation, the build of the docker file is completed, right? There is no error. Now if we go back to the docker desktop, can we see docker service is up and running? It is there, right? And that's all. Like, this is how we created our own image, our own service image, which is currently running on the Docker. Now, if you go there, so obviously there is no container is up and running, correct? So now give a try. Now let's try to create a container with our own created Docker image. We will also do the port mapping, and then we will see that how it works. So for that, what we can do is we can go to the terminal, we can clear the screen, we can say Docker images. This is the image that we have for our own image. Now we will say Docker run -d -p, because by default port we supplied as 300, correct? Let's try to see if the port mapping is working, because that port going to work on your Docker within the Docker container, but we wanted to use outside the container, right? So let's say we are saying that, hey Docker, you map your 3000 port with our 3000 port, okay? And you execute this image that we have created. This is the container that we have got. Now if I go to the Docker desktop, container is already there, which is like this. Now if we wanted to get into this container, can we do that? View details. Yeah, so right now if you see the container, it is actually showing the service port listening on the 3000. Now let's go back to the Postman, try to hit this. Yes, now the response that we are getting, this is from Docker. Okay, we can do one more test over here. So what we can do is we can go back, we can execute the same command, but this time what we can do is we can probably say that you map this 3000 port with 3001 of our local host. Now if I go back, try to change the port to 3001 and hit it, see, we are getting the response. That means our Docker image is working as expected. And also we have created a container, and the port mapping also happened correctly, right? And that's how we can create our own Docker file, and out of which we can build our own image. Okay. Now there is one more small thing over here, which is called caching the layers. So what does it means? So if you see that right now, this project, which is a very basic project that we have created, this project is only having like 3 4 files. But in a scalable project, we know that we can have multiple files in and out. Multiple files can be added or multiple files can be deleted, right? So the question is, okay, if that is the case, so we already have a Docker file, right? And probably we need to do another copy over here, because maybe there is some another dependent file that we are going to have. So we need to onboard this file as well. We need to copy that newly added file to our destination. So now the question is, if we make certain changes here, is that mean that and then we again rebuild the project, is that mean it always take that much of time? Because if you see that Docker file is actually contain this many steps, right? But due to the caching of layer, because whatever the steps we have written, right, like this is the step, these the steps, right? These are the steps is known as layers, right? So this is one of the layer, this is one of the layer to run some command here, then copy is another layer, then this is one of the layer, entry point is one of the layer. So what Docker does is Docker is actually caching these layers. That means until and unless we make changes into a specific layers, Docker already have the update, right? So if we don't touch our previous layers, right? So what and if we do something here maybe, then what Docker will do, Docker will just go inside it cache. It will check that, okay, I already have Ubuntu installed. I already have apt-get there. I already have curl. I already have Node.js. Then there is no need to re-download and install these things. I can fetch those things from the cache. So Docker will only focus on that specific line which has been added newly, right? So let's see that. So probably just to test this, I can add one random file, maybe utils.js, and this file is literally blank. We are not adding anything here. So I wanted to copy the same file. So I will say that utils.js, and also here that is utils.js. Okay, so this is the copy statement that we have added. Now our expectation is, if layer caching is working in Docker, then this much of line of code should not be re-executed, correct? So let's see that. So let's try to re-execute our docker build command, and this time if we see, it's simply executing the specific line of code, right? This time it took very less time, correct? So initially when we start our building, it's actually downloaded the Ubuntu and all those things, but this time we literally have all those things there. So what it is basically done, it's simply copied the utils and then our job is done. Okay, so the that's called the layers, the caching of the layers, right? So we have seen that once these are already there, so a Docker won't take much time. If you see, this is the new line that has been added here. Okay, let the execution done. So this is the new line just added, which is called utils.js, correct? And that's all. So whatever the things already there, it will just keep as it is. It will fetch from the cache, and whatever the new files that or anything maybe we have just added within the Docker file, it will consider that, and simply it will just rebuild the image because we have added something new, right? So that's called cache layering within the Docker, right? Okay, all right. Now we have something called publishing any image to the Docker hub, right? Now let's try to see that how we can push our own created image to the Docker hub. That is nothing but the Docker repository, right? So for that, we need to have the Docker hub credentials, right? And we also need to have the repository created, right? And few command we need to run, which I will show you while uploading that. So how it looks, so I already have logged into the Docker hub, so you simply go to the hub.docker.com, and there in the login, if we click, so if you sign up, right, it's a free of course, so you can sign up. And once you have signed up, so this is how the dashboard looks like. So currently I have 3 total images uploaded here, so it is looks like this. So for you it will be like, initially it will be empty. So here is an option called create repository. So if you go there, so it will ask that you can specify some repository, and not only that, we can specify some description like to access this repository, what type of version that you are maintaining, or how people has to use your image, if you have defined or specified some port informations, right? So those things can be mentioned over here. And also so this is called the first step, is we have to have the Docker credentials in terms of like login into the hub, okay, and prepare your project for uploading. Second step is pushing, which is nothing but the uploading. So all the steps and the respective command you can also see, which are mentioned over here, but still we will see from the respective command from a terminal as well. So currently I'm just clicking on it, cancel. And now let's go to the terminal. So let me clear this. So right now we already have seen that out of this Docker file, we already have the image created, right? So here first, Docker command that we need to run, that is called Docker login. So Docker login is basically trying to communicate your local host with the Docker hub. Okay. So initially, you won't get this login succeeded information or message, because for me I already did it. So what it will ask, right? So it will ask to enter your Docker Hub password. So whatever the Docker credentials that you are creating while signing up, you have to remember that. That is essential. Okay. So while running this command, which is called Docker login, it will ask for the username and as well as for the password, because from the CLI you wanted to make the connection to the Docker. Okay, and if the specified credentials are correct, then only you will be able to see the login succeed message. That means your specific localhost is now connected with the Docker Hub and with your respective account, and you can manage or you can upload or push the repository, that image, whatever you wanted to push over there. Correct. So now let's try to write the command. So command is docker, right? Docker tag. So for every each and every image that you wanted to push, for that you need to specify the tag. You need to create a tag. Okay. So our service name I would specify as a Docker service, and the tag that we will say as latest. So we are not going to specify any specific version or something. So we are saying that it's a latest tag only. And now I need to specify my username. So my username is Krishnendu, STET, then slash. So this is my username. Then I need to specify the on which repository that you wanted to upload it. So I would like to maintain, or I would like to create a repository with the same name, which is called Docker hyphen service, and that tag which is latest. Okay. If I can expand this a little bit, it can be more easier to see. Now, if I hit the enter button, see my command has been accepted, right? So that's the reason I am not getting any kind of an error. Now, this is something that we just created a repository and we specified with the tag. We created a tag for our image. Okay. Now, second step we need to do, which is called Docker push. Docker push. Now, after this, we need to say that this specific line we need to specify. Okay, so it's going to be your Docker username. So for my, it is Krishnendu STET slash Docker hyphen service, right? And I specified latest. If I do that, then it is saying it is actually my pushing process is now started. My uploading is actually happening, and it will take some time to complete this process. Now, if you see that my project, my image basically has been pushed successfully to the Docker. Now let's try to verify this. So let's go to the Docker Hub, and if we refresh this page, then can we see that? Krishnendu SDT slash Docker service. This is the specific image that we have created. And currently the visibility we set as public, right? That means anyone, whoever trying to see this, right, over the Docker Hub, they can see this, they can use it. Very interesting, isn't it, right? So even if you wanted to see that in public view how it looks, you click on the public view and it will take you to the like this, and now you have your own pull command exposed via Docker Hub now, correct? So now if we use this command, I should be able to install this image in my specific system, and I should be able to use my service. Let's do a demo. So for that, as we already running this image on our specific system, so for that what we can do is we can just go and manually stop this for now. We can delete this completely. Okay, so containers are deleted. We also wanted to delete all the images so that there is no such override thing happened or no such issues are happening. Now let's go to the terminal, clear the screen, simply write docker pull, and this is the, okay, so I already copied that command, so let me just modify this, right? Now if I say enter, so Docker should, okay. So for me, it is already there, I believe. That's the reason it is saying that it is already exists. Yes. So Ishnandu Docker SDT is already there. Awesome, isn't it? So now we can see that we already uploaded one service which essentially created by me, right? Which has been created by us, right? Then not only that, we have created a small service. We have written a Docker file to set up the service configuration, and we are also exposing the image by uploading the specific image to the Docker hub so that the same image can be used by the people, and that is what and that is what called as dockerizations of your applications, right? So for our understanding, what I can do is I can copy the commands from here, whatever we have basically segregated here, right? So that it can give us more clarity, and simply copy, paste it. And also this is the command that we have used for our, sorry, for our image push and all, right? So you don't worry, I will definitely mention all this entire whiteboard link to the first comment of the video, so you can just follow the same thing, right? Let's talk about the Docker Compose, right? So Docker Compose, so far, before starting up with this concept, so far whatever we discussed, right? So lastly, we completed these discussions where we have seen that, okay, we have a Docker file, and that Docker file is actually contains all the pre-configuration related steps that to build a specific project or to make the service up and running, what are the dependencies it requires, right? Okay, fine. So that is good. So far we are good. Now, as I mentioned previously, that when we are planning to work on a large scale project, right? So there we should expect that we're gonna have multiple applications and multiple dependencies. Right now, this is a very simple project, so we only one dependency we executed, that is like Node.js. But it may also possible that or maybe only one application we are currently running on, right? But it may also possible that my application also needs some email service, correct? And some other database service as well, correct? So I have to accumulate all the respective images in one shot. That means even though I have the Docker file, which is essentially saying that, okay, to run this service, I need to execute this step. So this is the part of image creation. Now, if I wanted to create multiple containers with all the dependent service that I have to make our service up and running, like database or email service, then what we can do, right? So as part of this solution, we have something called Docker Compose, right? So Docker Compose is actually helping us to run multiple image or containers. And as we have seen that when we are trying to execute or create or initiate any container, we are specifying the port. So the port mapping also we can define there. Okay. And also if there is any dependency on the environment variable, so that specific environment variable value also we can specify, right? So this is this is the part of Docker Compose that is actually helping us to do. The good part is with the help of Docker Compose, we can make our service scalable. right? Say for example that currently we are maybe running our service only one container, but there is a need, maybe the traffic is high, and now we need to scale up our container, right? So without think about like, okay, do I need to make any changes, or do I need to initiate multiple containers by my own, like manually? So Docker can help us to do it. We can simply specify that, okay, this is the service container I wanted to scale up by maybe 5 times additionally. So with some flag, with the help of Docker Compose, we can achieve that as well. Okay. So let's try to see that how we can create a Docker Compose for our own project. So for that, I'm just closing all the things and going to create a file which is called docker-compose, and the format can be YML. Okay, so if you focus on the format of the file name, right, that is docker hyphen compose, you need to specify, and there no hard and fast rule, like there is nothing like you have to keep the D as a capital. It should be like small as well. Okay, now at the very first we need to specify the version of the compose that we wanted to define, that which docker compose version we wanted to initiate. So we are going to initiate as 3.8. right now. We have to specify the applications. Okay, so those applications we will say as services. So as it's an viable, so services can have multiple applications, right? So currently in the project folder we have only one service, so that is something we will define. Okay, so under the services, the specific application where we are mapping our service, that is our Docker service, right? So for that we will create another scope and we will name it as app. Within the app we will say that you run an image. So right now we already have an image, right? So we already created an image out of the, like, for our own service, and the image name we said as Docker service. So this is the image that we wanted to execute, correct? Now the question is, okay, if this is the image that we wanted to build, right, then how we can build this image, correct? So basically what I mean to say is, like, if this is the image we wanted to build, which name as docker hyphen service, then where the steps has been written via which we can identify, like Docker can identify and make all the precondition details ready and gradually build this image. So those steps we already specify within the Docker file, right? So we need to just specify the Docker file reference over here. So that can comes under a tag called build, and this build going to have some sub tags. One is context. So context going to be dot basically saying the root folder, and within that we have another tag which is called Dockerfile, and in the Dockerfile, against the Dockerfile, we just need to specify what is the Dockerfile path basically. So our Dockerfile for our project right now, it placed under the root folder, that's why its context is dot, and Dockerfile name is capital Dockerfile, right? Capital Dockerfile, and that's it, like build is done, correct? Now we also wanted to tell to the Docker that, okay, if like we have built this image, right? So whatever the steps we did manually, right, in the previous discussions, whatever the steps we did manually, right? So what are the steps we did manually? We ran docker build command manually to create the image out of the Docker file. Once the image is created, then we again ran another command to initiate a container on top, like which can execute the image, right? So we ran like docker run hyphen d and then image name. So those are like manual steps we did, but Docker Compose giving us the flexibility where those manual steps we can do it automatically. Okay, so we can instruct Docker Compose here, and Docker will take care of all of this. So here at the first layer, what Docker Compose is doing, Docker Compose is simply creating the image out of this Docker file. Now we are going to say that once the image is created, you also start a container with the image that you are going to create, which is called Docker service. And that specific service you map us, that specific service you map us within the port called 3000, within the port called 3000. Okay, so this is the port that we wanted to have. Now we will add another tag which is called volumes. Now what's the concept of volume? So volume is like, if you see, whenever we are running some container, right, whenever we are running some image or maybe the container, so containers, so anyways it's gone, even though image is, right, so this configuration, and when our need is done we are actually deleting it, right? But there is a way that we can actually save the configuration within the Docker itself, that is going to mount within the Docker, and which is called volume. Okay, so we are saying that you not only like build the Docker service image uh, by referring the Docker file that we have created, you also create a container, okay, which can run this service. And once that is done, you also save the details of the application into the volume. So this is the app which our parent of each and every image, right? So this is the app which is having all the information about the image. So we are saying that, okay, actually the indentation should be under the build like this. Okay, so we have to be very much careful about this about this uh, about these lines. Okay, otherwise it can throw some exception to us. So let me just try to modify this. Yeah. So app, right? So app contains all the details here. So app is basically having all the details. So we are saying once the image is built, once container is created and has already been mapped, you please save this configuration and you please mount this configuration under the volumes. So then in the future, if there is any need, then we can directly get it from there. Okay. And we will also say that restart always. Restart always, what's the mean of it? That while creating the image out of the Docker file, or while creating or initiating the container for this image, if there is any problem occurred and restart is required, you please restart and then you start. Okay, or maybe probably we are running the compose multiple times, so second time once we try to execute, you first restart it, then you start downloading and referring all those things, whatever the instruction we have provided, right? So this is the very simple format of Docker Compose. So here one thing that if you observe that whatever the steps we have performed manually, right, like even though we have created Docker file, but still we have to run the command called docker build -t and then application name and dot. Then once the build is completed, then again we have to create the container to run the image, that is also manually, right? But here Docker Compose is taking all the responsibility. It is saying that you just guide me that what exactly the things needs to be done, right? Do you want to create an image? Yes. Then the specify the information to me. You want to create a container? Yes. Specify me that on which port you wanted to expose it. You wanted to save the configuration? We said yes. So we specify the information here. So now with that, if we try to execute our line of code, right? So to execute the Docker compose, we need to say Docker hyphen compose, and we just need to say that up. Up means we are trying to say that you initiate the container with whatever the image that we defined. So if you hit the enter, it is saying that apps port must be a list. So there is some problem happened. Maybe let me verify. Problem is with this, it looks like yes. Okay, so there is some space issue. Now it should work. Okay, additional property restart is not allowed. Again, it's a problem with this proper alignment. Okay, so that's the problem. we need to just look, we need to be careful. Yes, so I have fixed that, right? Whatever the problem that we are facing. So there is an alignment problem with restart as well. Now let's try to run the command again, which is docker compose and then hyphen u, sorry, space up. So now it is taking the format and it is saying app is pulling right now. Okay, so we are not specified any docker login, so that's fine. Now if you're seeing, it actually did all the things, right? It's actually created the image, then it's right now it is network, which is like default network, it is coming under. So it's a part of docker network. We probably target this concept of docker network in some other session. And now it is also saying that it started a container called this with this specific image. So let's see our docker desktop. And yes, there is a container called sorry, there is an image called express service. Okay, my bad, sorry. I think I did some mistake. Okay, so what I have done is like mistakenly I just put it the previous name, right? The image name we specified as express hyphen service. So to change that, what we can do is we can stop it. Yes, and clear this one because we are following one common image name. Na? So let's try to follow the same, otherwise it can create confusions. So you will say that Docker service can be my image. Now let's give a try. So it just running the specific steps. It is already there, so it should not take much time this time because of the cache layering, right? And now it is recreated. Now let's try to verify. Yes, now Docker service is there and container is also there. So Docker Express service, which is our container, and it's contain the Docker service, right? It's contain the Docker service and which has been exposed to the 3000 port because we specified this port here, which is 3000. Now if we wanted to run our local host, it is saying that currently it is unable to. Okay, so we are running on the 30001. Let me make it 3000 and now it should work. Awesome, right? So Docker Compose is actually helping me to make my service not only build the image out of the Docker file that we have created, but also it is initiating the container as well, which is the best part out of it, right? Now the manual intervention is almost almost like end, correct? So all right, let me stop all these containers, right? And if I go back and manually try to delete all this, delete forever for now, build. Yeah, so I was talking about the build, right? So initially if you see that, my build was empty, but as we are mounting this in these details like Docker Express, wherever our details are there, that's the reason Docker already saved this build history, like this information to here. So even this image also, for the time being, if we try to delete this, and now let's say I wanted to have one more scenario to be addressed. Let's say there is a ask that okay, whatever the image I have currently, maybe there is a demand where I wanted to instantiate 5 containers with the same image that we are building. 5 containers in one go, correct? Then how we can do this? Let's give a try with Docker Compose. So for that, Docker Compose up, right? And then there is a flag called scale, and then which service that we wanted to write, maybe Docker service that I wanted to use for 5 containers. So it is saying that this version is obsolete, service not found. Then what we can do is Okay, so there is a small mistake onto the command that I made. So let's try to like again, let's see that what exactly the correction that we need to do here, right? So in terms of in scaling up our service or our container, we need to run docker hyphen compose and then up, that is the common one. Then we said we need to add one more flag called hyphen hyphen scale, and this is the application name we need to supply. So initially I was doing like I was passing this image name, but that's not the correct one. We have to say app. Let's say I wanted to increase 5 container, right? So the so the expectation is once my building is done, the image is completed, building image building is completed. Now I wanted to instantiate 5 containers which can run the same image. So for the time being, before executing this command, we can see image section is blank, container is also blank, right? So let's go back here, try to hit the enter. You can see it is saying it is running the steps and completing all the steps, and finally if you see it is creating 5 containers, right? So let's try to verify this. So only one image we have. Now if I go to the container, wow, so I have total 5 apps created with only one command, which is called docker compose hyphen hyphen scale and then equal to 5, right? So this is the power of docker compose, correct? So now let's say I have total 5 container that we already created here, right? Now let's say I wanted to remove 2 of the containers from it, right? So let's try to do the play around with it. So let me clear the logs, right? Now let's try to write the same command, which is called docker compose and then up hyphen hyphen scale app equal to 3. The same command, only count we are decreasing. This time if you see it is saying 4 or 5 has been removed and 1 is already there, right? So for that, now if we try to see there, so 4 5 has been removed and 1 2 3 is there. Similarly, now let's say my entire container need is done, right? I don't need any container. I wanted to remove this whatever the container we have started. So for that we can use docker compose down command. Okay, down. So if I do that, then whatever the container was there, it's now removed. We can verify the container is empty and image is there, right? So this is the docker compose that we have discussed so far, correct? Let's see that how we can supply the environment variables via Docker Compose, right? So as per the service we have designed, we said that we have a port as a variable, which is which can be an environment variable. So if user wants, they can supply certain variable like certain port as an environment variable, say 3001, and if not, then the default port that we supplied, which is like 3000, correct? So far it is the thing that currently our service is running on the 3000 port. Now if there is some .env file if we have in our project, then how we can supply that, and we can make or we can refer the specific .env file via our docker compose file. That is something we will see. So for that, this is the project we are here. So we can simply create a file which is called .env, and here we can specify a variable name called port, and this time we will say that port number is 3001. Now let's come back to the YML, and just after this image, take a new enter, a new space, and here we can just specify env file and just specify the name of the environment file. So for us, the environment file is .env. Now, so far it is fine, but we need to specify this port as a variable, correct? Because we wanted to map this port number which has been specified within the file. So that we need to specify as part of the variable. So how we can do that? We can say dollar curly braces code and also dollar curly braces code and save it. Now if we say docker compose and up, then what it will do is it will say that yes, our container is created and currently it is listening on the 3001. Let's try to verify this. So it is 3001 in our postman, and currently if we hit the send button, it should give me the output. So that is how we can also specify the port via our environment variable, right? Okay, so apart from that, whatever the topics that we covered, right, we have referred and created a service using Express.js, which is a part of your Node.js, right? And we also understand that there can be a need that where we wanted to create a Docker file for our simple Java-based project as well. So just to keep this thing in our mind, what I have done is like I have also created a very simple project, okay, which is a simple Java project. We don't have any Maven or something like that, right? And we will see that if we have this kind of project also, then how we can build a Docker file out of this, or how we can basically build an image out of a Docker image out of this project, right? So let's try to just understand a very basic and simple project. So the project name I have provided as music library. What this does basically, so there I have just written couple of controllers and model. So these controllers and model responsibility, like it can have a music library controller, so we can do the add genre, we can display the library, we can add singers, we can add songs. So these are the various method that we have created. Now from the main.java, what we are doing is we are just supplying few of the inputs. Like you can see, we are adding some songs like Shape of You and Perfect. We are adding the artist or singer like Ed Sheeran, and we are also modifying the singer from Ed Sheeran to Arijit Singh. We are also modifying the genre, and then we are deleting the song. So this is what this entire music library does. We literally don't have any database, any Maven dependency, nothing. It's a simple Java-based project, right? So quickly just run this project just to make sure that yes, our project is up and running or not. So I'm just running the project. It will take some time just to build it. Yeah, so you can see we are getting the proper output here. So add song, modify song, delete song, all those things are happening properly, right? Now let's say I wanted to create a Docker file for this project, right? So before that, there are few steps that we need to follow. Just let me mention those. That first of all, we have to make sure that as it's a simple Java based project, we need to have a jar file, because see, ultimately via image we wanted to build the project, right? Then Java project, how we can build, we can build if we have an archive file which can be built, like which can be deployable, or like compiled properly. So using the Java compile or Java C command, we can compile the entire project, and then we can have the out folder, and accordingly we can also have to generate the music library like jar file. For me, I already proceed with those steps and I already have the jar file created, right? Now, after that, we also need to create a manifest.mf file. It just to provide the reference like what is our entry point. So if you remember, we mentioned one entry point in our Docker file for our previous project, right? So main is nothing but our main class from where it can start, and class path is the root. So that's what we provided the dot. Now we can also create like this, right click and new, and then we can take a file, and here we can supply it like Docker file. So for me, I already created, just to fast forward this. So now if we see the Docker file content is empty, and now we can enter few of the things. So as just like our previous example, there we have started with Ubuntu installation, but here I would like to introduce one thing, that Docker file writing also we can optimize, right? So here for Java based project, if we can use the OpenJDK, and if you go to this Docker Hub, right? If you just simply click on the Docker Hub, right, which is this, and if we already wanted to see that, do we have any image already available for OpenJDK, right? Then we do not need to essentially create any or essentially need to have any dependency on so and so operating system. So we can say OpenJDK, and yes, we can actually see that there are a couple of images are available for OpenJDK. So if OpenJDK image is already available with us, that means OpenJDK community already built all the required things over there. That means if we simply use the OpenJDK, then we do not need to add any other instruction for onboard any new environment, sorry, new operating system and all, right? So now our steps going to be very less. So we will say that first we wanted to capture our OpenJDK, and the version I wanted to specify is 11 JRE, and this is a slim. So this is the tag that I have added. So I wanted to tell to my Docker that, hey, you go to the Docker Hub and download the specific image called OpenJDK 11-JRE-slim. Now I wanted to write one tag or one keyword called work dir. So work dir is basically the working directory. So here if I specify the steps, so it's basically saying that specifying the working directory. So it means that once our image is created and out of that was content, like image, we know that it's going to create in so and so operating system, right? There we are going to say that you create, and already you have a app folder. If not there, then you create a app folder, and there you pull all the dependent information there and make it as a working directory. So for any IDE, right, be it's IntelliJ or Eclipse or VS Code, whenever we try to create a project or working on a project, we always create a working directory, right? So we are just specifying that within the image or within the container, you target app folder as your working directory and do your job there. Okay. Now we will simply copy what we wanted to copy. So we wanted to copy our music library.jar, because this is where our entire library or code has been archived. So we can simply take the exact name and do it. Okay, so it will simply copy, and we can say that dot. So here if you see a small change I have done, right? So if I compare my previous Docker file from VS Code, where we have said that if copy is like this, where source is like this and destination also like this, right? So we mentioned that if we are putting a specific file name, which is my source, so the best practice says that you can specify the same name to our destination. But here you can say, Krishnendu, here you says that you wanted to copy music library from your source. But what about this? You specified dot. That's a very valid question. We specified dot. Why? Because we have specifically mentioned the working directory. So Docker will automatically understand that user says destination as dot means user wanted to save this specific file from the source within this working directory called app with the same name. Now if you wanted to change it, you can change it. Okay, but as I mentioned, as part of the good practice, we can keep it like this. So this is because of working directory we set up, so we do not need to specify it. If you just simply specify dot, that should be fine. Now, as this is the program we wanted to run on the command prompt, so command prompt going to be replace our entry point, right? And how we can trigger any jar file. So to trigger any jar file, the command is says java hyphen jar, and whatever the jar file you wanted to execute, that name you simply specify, right? So the syntax is java hyphen jar and then your jar file name with extension .jar. The same thing we have done here, right? So CMD, we are saying that once you do this, like once you pull your OpenJDK image, which has to be installed properly with all the dependent operating system. Now you define your app is an working directory. There you just simply take our music library.jar because that should have all the dependent informations. And now on the cmd command prompt, you run this command so that this jar can be executed. Now let's try to open the terminal and try to run the same command, which is called docker build -d. I would like to specify my image as music library service dot. Let's see that it started building. If you see, it's desktop Linux, right? Okay, it is saying music library repository must be in lowercase. Okay, so let's try to just change it. So it is saying it should be, it is a case sensitive, sorry, so it should be small l music library and then hit enter. Awesome. So it has been taken, but we have some exception over here. Let's try to identify. Okay, here if you see, we have added some additional space. That shouldn't be the case. We can just clear this. Try to re-execute. Error we are getting. Let's try to identify what's the error. So let's try to add some space because I think there was no space previously. And then let's do a try. This time. Okay. Okay. All right. So now if we can see for a Java based project also, we are successfully able to expose an image with the help of Dockerfile. Correct. And now if we just wanted to verify this, then go back to the image. Now music library service is up and running. Now go to the terminal. Again, if you wanted to create a container for this, then you say docker images. Sorry, it's a bad instruction. Docker images it should be. Let me delete and rewrite the command. So this is my image copy. I'm just copying the image id, then I'm saying docker run -d, and this is the name of my image I'm specifying. You give me a container, and now if I go back, try to see here, my container is running. Yes, and if we wanted to see, so this is what my container is already been created, right? So this is how we can also create a specific Java like a Docker file for a Java based project. The difference we need to understand, and there as an entry point we specify like node and then specific entry point here. Here, as we are building the entire project in the format of jar file, that's the reason we have used cmd, so that on the command prompt my Java file, my jar file can be executed, and then gradually we can get the image, right? So I hope this session makes you like very much helpful. It very much helpful to you, and it definitely help to proceed for your uh, future endeavors.